All right, what's up guys? In this video, we're going to pick up with some more calculus, and this is just going to be another integration practice video. And this is going to be example number 1 of the integration practice series. So this will be example number 1. Okay, so we're asked to evaluate the integral sine of the square root of x dx. So obviously we can just start with a u substitution, picking u to be the square root of x. Take the derivative of that. Remember, the derivative of square root of x is 1 over 2 multiplied by the square root of x dx. Use the chain rule for that. And then if you were to solve for the dx part, you'll get 2 times the square root of x du is equal to dx. So the 2 is a constant and can be brought out. So I'm going to factor it out front. And what we'll have is the integral, looks like we'll have u times sine of u all integrated with respect to u. Okay, and so now we need to evaluate this integral. So we got u times sine of u du. So this is a perfect time to use integration by parts because we have a product of 2 different functions. So we'll use integration by parts next. Remember, integration by parts, the formula for that is the integral of u dv is equal to uv minus the integral of v du. And we need to determine what u is, and dv will be everything else. So what would be the best selection for u? So again, neither one of these is harder to integrate or differentiate than the other, but in this case, I'm going to let u equal u, and that means the dv is everything else. So dv would be sine of u du. So du is du, and then v is the antiderivative of dv, which is the antiderivative of sine of u du, which we know as a negative cosine of u. So now, using our integration by parts formula, remember the 2 was a constant that was factored out front. Remember, multiplication is commutative, meaning you can do it in any order and get the same answers. You can kind of clean this left side up however you want to by bringing the negative in front. That's what I'm going to do. So I'm going to have it as negative u times cosine of u minus the integral of, it looks like we'll get negative cosine of u integrated with respect to u. And we know that when we integrate negative cosine, we'll get negative sine because the antiderivative of cosine is positive sine, but if we stick a negative in front of it, it becomes negative sine. And if you notice, we'll have a negative here and a negative there, so therefore it'll change to a positive, so that'll actually become plus sine u. So we got our 2 that was factored out front. Remember, we didn't touch the left side over here, so that was minus u times cosine of u, but this time this changes to plus sine of u. And now all we have to do to finish this up is just put the u back in. So remember, our u was the square root of x for our original u substitution at the top. So all we got to do is plug that back in there and expand out the expression a little bit to get the final answer. So we're going to kill 2 birds with 1 stone. So the final answer for this integral, we're asked to integrate sine of the square root of x dx. So the answer to this integral will be negative 2 times the square root of x multiplied by cosine of the square root of x plus 2 sine of the square root of x. And then it's an indefinite integral, so we need to add an integration constant plus c at the end. And that would be your solution. So relatively simple example for this one. Hopefully one that wasn't too hard. All right, so that was example number 1. So let me know if you got any questions about how I got the answer, or I would be more than happy to explain it. All right, but y'all take care, and I will see y'all for the next one.